Alright, in this part we're actually going to do something interesting, which is find the answer to a differential equation. So a differential equation is simply an equation that has a derivative in it. So here you see f prime is equal to negative 2 f of x. That's a differential equation. The value of the function actually affects its derivative. So what we want is to find, like all equations, we just want to find the answer to this equation that can go here and here so that both sides are equal. So you can see that we have a fundamental connection between our function and our derivative. So the question we want to ask ourselves is, what is a function that's actually the derivative of itself? And we saw from earlier videos that that answer was e to the x. So I'm just going to show you the answer to this and show you why it works. So the answer to this is e to the negative 2x. Do you see that this video would, do you see that this function would work? Notice that if I take the derivative of e to the negative 2x, the negative 2 comes down in front, and I get negative 2 e to the negative 2x. In other words, my derivative is equal to my function. The derivative would be negative 2 e to the negative 2x, and this would be negative 2 e to the negative 2x. So hopefully you see that if I plug in the function here in front of the negative 2 and plug in the function here and take its derivative, I get the same thing on both sides. It actually turns out that we can do one step better than e to the negative 2x. The best thing we could do, I'm going to write our function again, our equation. It turns out that the best we can do is c e to the negative 2x. This is called a family of solutions or a general solution. It turns out that it doesn't matter what number we put in front of e to the negative 2x, it will still work. Let's see why. If I take this and plug it into this right-hand side, I would get negative 2c e to the negative 2x. If I take c e to the negative 2x and plug it into this side, I take the derivative, so the negative 2 comes in front, and then it's just phi e to the negative 2x. The negative 2 coming in front because of the chain rule. So notice, oops, that's not a parenthesis. My c looks like a parenthesis, so that's an unfortunate letter. So notice I get the same thing on both sides, negative 2c e to the negative 2x. So this is the answer. This is the best answer. This is the family of solutions that solve this differential equation. Now let's look at this differential equation. We have dA dt equals negative 9a. Again, e to the negative 9a would be enough, or let's actually use t. We're taking the derivative with respect to t, so we should write e to the negative 9t. Notice that if I took the derivative of that, I would get negative 9e to the negative 9t, or if I just plug it in right there, I get negative 9e to the negative 9t. As we saw before, we can slap a c out in front, and that's the answer. So c e to the negative 9t. There's an entire class you can take on differential equations. You'll notice that e to the x is an important idea for solving them because e to the x is a function who is its own derivative. All right, we'll look at some more applications in the next video.